and this is Tommy Teaches Algebra, Episode 2, Algebraic Expressions. Now, an algebraic expression is a number written with algebraic symbols. For example, 5a plus 2b is an algebraic expression. You could also have any combination of multiplication, division, exponents, parentheses, terms. A term is an algebraic expression that's not separated by a plus or a minus. So 5xy or 2a is a term in an algebraic expression. You could have more things added or subtracted on, but it's just the part. It's just the single term in the expression. Simple expressions. An algebraic expression of one term is called a simple expression or monomial. So 5xy, 7a, 2b, those are simple expressions. Compound expressions. An algebraic expression of two or more terms is called a compound expression or polynomial. So 5xy plus 7a, or 2x minus y minus 3z, or 4a minus 3b plus 2c minus 3d are compound expressions. A polynomial can have any number of terms. A binomial has two terms and a trinomial has three terms. 3a minus b is a binomial. 3a minus b plus c is a trinomial. So polynomials, binomials, and trinomials all exist, and they can be completely natural and even rational. Positive and negative terms. Now, the terms of a compound expression preceded by the plus sign are obviously positive terms, but the terms preceded by the minus sign are called negative terms. If we leave the sign off, it's automatically assumed positive, if you'll remember that from the last episode. Positive and a negative term of the same numerical value will cancel each other out when combined. Now that means when they are added together. Like terms. Terms which have the same combination of letters are called like or similar terms. So you can add 5a to 7a and get 12a. Or you can subtract 7a from 5a and get 2a. That's called combining like terms. Now, if they do not have the same combination of letters, they're called unlike or dissimilar terms. So 5a squared bc, 5ab squared c, and 5abc squared are unlike terms. You cannot add them together. So the degree of a term. A term that is the product of three letters is said to be of the third degree. A term of four letters is said to be the fourth degree, and so on. You get the idea. Thus, 5abc is the third degree, or 2a squared b squared c squared is the sixth degree, because that's 2a times a times b times b times c times c. Now, the degree of a compound expression is usually expressed in the term of the highest degree. A squared x squared plus bx plus c is the fourth degree, since a squared x squared is the fourth degree. But most of the time we want to know about the dominant letter. And it happens that one letter in particular is more important than the rest, or that's the whole thing we're looking for, and it's called the dominant letter. In such cases, the degree of the expression is expressed in terms of the dominant letter. So a squared x squared plus bx plus c is of the second degree in x, x being the dominant letter. The arrangement of a compound expression. A compound expression is said to be arranged according to the powers of some letter when the exponents of that letter, reckoning from left to right, either descend or ascend in the order of magnitude. So 3ax cubed minus 4bx squared minus 6ax plus 8b is arranged according to the descending powers of x. But 8b minus 6ax minus 4bx squared plus 3ax cubed is arranged according to the ascending powers of x. Now, if you have a mixture of x squared and y squared, sometimes you will write descending in the dominant letter, but ascending in a secondary letter as you descend in the dominant letter. For example, x squared plus 2xy plus y squared. As you see, x goes from 2 to 1 to 0, and y goes from 0 to 1 to 2. Now, parentheses. Now, if a compound expression is to be treated as a whole, it is enclosed in parentheses. So 2x times the quantity, or in parentheses, 10 plus 5 means that we add 5 to 10 before we multiply the result by 2. If we were to omit the parentheses and write 2 times 10 plus 5, we would multiply the 2 times the 10 and then add the 5. Now, I talked last time about the signs of aggregation, which can be brackets, braces, and I mentioned the bar and the vinculum, all those things that are like parentheses and can be used to aggregate. So we just treat all of those the same for now in algebra. You just treat them as parentheses and solve inside the parentheses before you multiply through or add to anything else. In the case of a parentheses preceded by a plus sign, if a man has $10 and afterwards collects $3 and then $2, it makes no difference whether he adds the $3 to the $10 and then the $2, or puts the $3 and $2 together and adds their sum to his $10. So the first one we would say 10 plus 3 plus 2. But the second way we would say 10 plus the quantity, or in parentheses, 3 plus 2. Hence, 10 plus the quantity, 3 plus 2, is equal to 10 plus 3 plus 2. But if a man has $10 and afterwards collects $3 and then pays a bill of $2, it makes no difference whether he adds the $3 collected to his $10 and pays out his sum, $2, or pays the $2 from the $3 collected and then adds it to the $10. So 10 plus 3 minus 2, or 10 plus the quantity of 3 minus 2. So if you're just dealing with addition and subtraction in parentheses, you can clear the parentheses automatically. If a parentheses is preceded by a minus sign, you multiply minus 1 by everything inside the parentheses. Otherwise, that also means you just change the sign of every number inside the parentheses. And here's the example. If a man has $10 and has to pay 2 bills, one of $3 and one of $2, it makes no difference whether he takes $3 and $2 in succession or takes the $3 and $2 at one time for his $10. The first process is written by 10 minus 3 minus 2, or 10 minus the quantity of 3 plus 2. So 10 minus the quantity 3 plus 2 is equal to 10 minus 3 minus 2. So in that case, we put a minus in front of the 3, and we change the plus on the 2 to a minus. So down in the description you'll find a homework assignment for this week. It's 21 very easy problems that should not take you more than 5 minutes. And then the next time I have an episode, I'll have the answer key for you and another exercise. These should be pretty simple at first. The one today is all about clearing parentheses. So if you know how to handle parentheses with simple addition and subtraction, you'll be in really good shape. Thanks for watching this week. And if you know somebody that could use a little boost in their algebra, hit the share button and send it to them. If you like this video, give it a thumbs up. And if you feel like you need algebra in your own life, hit that subscribe button and come back in a few days when we'll go on to the next topic. I'm Tommy, and this is Tommy Teaches Algebra. If you'd like to see the first episode, click here. If you'd like to see me doing something else, like cooking, click here.